Welcome. Thank you for having us here. We are the Eagle Eye Engineering Team. We're going to present our dynamic archery stand. We're all mechanical engineering students right now. We're soon to be graduating. My name is Jordan Schramm. I'm the team lead. I've had a lot of leadership experience through internships with NASA and various projects.
I'm Joseph Shannon. I'm the design lead for the team. I have experience at Go Green Solar as a project engineer and specialize in CAD design.
I'm Sean Morgan. I am the research lead, and I have experience with Mitsubishi Heavy Industries America.
My name is Nick Heimer, and I'm currently an intern at Element Wide Engineering, research or quality and safety lead.
Good afternoon. My name is Rahul Latif. I am the marketing lead, and I currently serve as the student body president here at NASA. So let's start off with archery real quick. Historically, archery has been used for hunting and combat. Nowadays, it's mostly used for recreational activities. Typically, two types of competition. You have indoor archery and you have outdoor archery. Indoor archery pretty much ranges from 18 meters, but in outdoor archery, it can range anywhere from 30 to 50 to 70 to even 90 meters. That's almost a football field when it comes down to it. We also want to look at some of the numbers. This number is going to surprise you. In the United States, there are 18.9 million people who participate in archery, whether it's field archery or remote hunting. That's largely due to some of these movies, and I'm sure you all know that. And then you have Brave, and you have some of these TV shows. But at the same time, this number has steadily increased by 20% per year for the last 2 years. We also want to look at the demographic of this. Where are these people located? 33% of them are located in the Midwest. At the same time, 33% of them are also located in small towns and small cities. So that poses a question and a problem as well. 80% of these are impacted by weather. And at the same time, 70% of them are impacted by space constraints. In Orange County alone, with a population of about 3 million people, there are only 4 outdoor archery ranges. Now, let's look at some of the different associations that are affiliated as well. You have the National Field Archery Association with over 49 charter states, 1,000 affiliated clubs. You have the collegiate associations as well, at the same time you have the national field archery associations. Each one of their events have 800 participants. These are members from different countries. At the same time, you have the Olympics Archery Association as well, with over 600 development programs. And you can't forget about some of those private ranges as well. Now comes the problem. The problem is, 3 to 5 months out of the year, there's winter, and so archers cannot practice outdoors. So they lose valuable time and valuable skills that they can be preparing for those competitions. That proves to the development of arm muscles and muscle memory and all that, so they're not able to be prepared for some of these competitions. And these are, there we go. And some of those angles as well. So when archers are practicing outdoors, they're looking at different angles. And these angles also correlate to the different distances. So our solution, as can be seen in that prototype to your right, is also an archery stand that can emulate outdoor shooting indoors through different features. One feature being it's able to rise up and down, correlating with different distances. And there's another feature as well, we provided and calculated through testing a target emulated image as well, that they will be able to explain in further detail.
So in order to successfully emulate shooting outdoor distances indoors, we need to start with the target face. This is a target face that you would currently see when you're shooting from 50 to 90 meters. But now, when you bring this closer to you, you need to scale this down. And so through mathematics and geometry, we've done this here. And currently, our CSUF archery team has been using these to practice, and it's given them a great competitive advantage. To develop some skill in building our stance, we started small. We started with the current target butts used by the CSUF archery team. We were able to find the limitations of their facilities. And from this, we were able to develop our beta prototype, testing our algorithm of these different heights with the various speeds and different bow types. It can be seen over here, it's quite large. So by understanding the facilities, as well as our stand knowledge, we're able to do a pre-production prototype that we can bring to a manufacturer, greatly reducing their lead time in getting this product to market. We want it to be a simple interface where the archer would simply input their velocity bow speed, the distance they want to emulate, and the target would rise to the appropriate setting. Let me go a little bit into the algorithm. I'll save you all the mathematics, even though that's what us as engineers we get really excited about. So an overview is we took impact height settings versus the site setting on the boat. From this, we were able to determine or compare to someone's actual site setting. From this, we can develop a plot and through mathematical manipulation, determine the emulated distance and height of the target we need to be at. What's a competitive advantage? We're going to be first to market. There's no prior technology of this kind of standard with these features. We're also going to be ownership of the intellectual property. We're going to own the algorithm. And as well, we're going to copyright these target bases that I showed earlier. We're currently in the process of submitting these applications and hope to be done early May. So now how are we going to make money with this? We've looked at 3 options. Option 1, we can develop and manufacture the entire system. There's a lot of profit involved in this, and we maintain control of the intellectual property. However, we have to raise a lot of capital in order to do this, and this is a high risk. So we look at option 2. We sell the entire patent license. This mitigates our risk. However, we lose total control of the intellectual property that we have. So we've been leaning towards option 3. Option 3 is to collect royalties off of this patent and license. With this option, there's less risk involved. We maintain a cash flow as well as control of the intellectual property. So bringing this idea to market, we've already contacted Morel, which is a large car company in the target industry. And they've shown great interest in our product and idea. We're also looking to gain attention through our CSUF marketing team, bringing it to competitions, and tomorrow we'll be showcasing our prototype at welcoming Cal State Fuller today. Who are our potential customers? As I mentioned before, we've contacted Morel. There's also American Whitetail, and they hold 80% of the target bud industry. So as with any business, there's some barriers to entry as well as external factors. Our barrier to entry, we need to patent and copyright our technology before approaching these companies to protect ourselves. There also could be some undiscovered patent issues. This, we've done in-depth research into the patents and don't see this happening. Also, there could be a sudden decrease in archery, but since it's been increasing by 20% per year for the last 2 years, we do not foresee this happening. So let me pass it back to Rabula. He will finish explaining the finances.
Now let's look at some of the expenses. We looked at spending about $4,000 when it comes to research and development. That's due to some of the materials. It also covers some of the purchase fabrication thing. We looked at about $2,100 to take care of some of our IP, some of the admin fees. We want to brand ourselves in these bow ties, so we gotta add some of that cost into it as well. We want to stand out. We want to make sure we're out there and we're visible. At the same time, when we're looking into the marketing and consulting expenses as well, we looked at about sending 2 individuals down to the Midwest to go and present this concept to some of these large manufacturing companies, such as Morel, such as American Whitetail. That's going to cost about $100. Adding that up as well with the consultants. We're engineers. We understand we don't have some of that accounting experience, so we might need some people that can take up that for us. We looked at that about $1,100. And through this competition, we're also looking to get some in-kind support from them. Now let's look at how much it costs for the amount of labor and time that we have committed right now. From the beginning, about 6 months ago that we started, to now when we've developed the concept, it costs about $27,000. That's from everything down the road to this day where we're presenting in front of you right now. So let's package all this up in a total licensing fee. Remember, we're going for the licensing fee and the patent fee. It's going to come out to about $52,000 that we're asking for. Now this means that from the beginning, all the hard work, everything we've done, from the stands, from travel, to the marketing, that's going to come down to about $45,000, in addition to the 50% profit that we're adding to it, totaling to that $52,000. When we go to manufacturers, we're going to ask them for this upfront cost, which is going to be this $50,000. Now that number is quite minimal to what it would cost for these companies to start doing what we did, to start emulating the hard work that we put into it. That's going to come out to about $220,000 for one of these large companies to go out there and start the concept, bring it all the way down to where we are today. Remember, we knew the vision, we have the direction, while some of these companies might try to find the map. So it's going to cost about that much, and engineers are not cheap. All those numbers are going to total up, especially when we make mistakes and we learn from it, we go back and research and development. So we accumulated about $220,000. In addition to some of the materials, that's going to total up to $226,000, as opposed to our $2,000 that it took us. We want to look at the value proposition analysis as well. It's going to be 23% of cost of doing it from scratch. It's going to bring these companies 4.5 months closer to revenue centers. At the same time, it's also dramatically reducing some of these development risks that they'll be running. We're only asking for about 3% royalty fees, and we're not including some of the royalty fees or upfront costs for some of these target bases that we've also created, which is our algorithms. When we look at some of these companies, we showed you some of our production design earlier. It's going to cost about $93,000 to go from that to complete that entire production design. But if you look at the 3-year projection for some of these companies, it's going to be some good numbers over here. If we look at the first year and we say the standard will cost around $1,000 in SRP, and that includes the rack cost of $670 when it comes to some of the fabrications, and the labor, some of the overhead costs, and of course they also want to attach about $330 of the profit for themselves. That's going to come to about $1,000 per stand. I want to also tell you something. The current stand, the current range right now, costs over $5,000 to create. That's, I'm lowballing that number right now. This is just a calcium floats and archery range. Other ranges can cost over $12,000, even greater, to create a range to complete for archers. So asking for $1,000 is pretty low in that case. And we're asking about 12, if they're the first year to sell about 1,200 stands. That's going to be 100 stands a month. And if each one of these ranges, they typically have the minimum, they have about 5 different stands. Now, that's the minimum. Some of these large ranges, they'll probably have over 20 stands. So we're asking some of these companies, they're going to be selling these 100 stands a month. They need to find 20 potential customers, and they can send about a minimum of 5 for each customer. Numbers are reasonable. So that's where we got our 1,200 from. And the expense is about $804,000. They were bringing an income of about $1.2 million, netting a gross profit of $396,000 the first year. But let's take out their production development cost of $93,000, and the licensing fee that we're going to be asking them is about $52,000. Of course, we can't forget about royalty fees, about $7,000. They're going to be making a raw net profit of over $240,000 in the first year. Second year, there's not going to be a development cost because the development's already been done. There's not going to be a licensing fee because that's only for the first year what we're asking. But there will be a royalty fee of about $7,000. And so on. First, second year is going to be $594,000, and third year is going to be around $891,000. They'll be able to recover the cost in 5 months. Some of the challenges we're going to look at, the skills that we have right now, we're all engineering students, we're going to be graduating. We passed our entry-level engineering exam, so we're ready to go, we're ready to go in the field. The team has been in contact with Morel, one of these large companies, and they have shown interest in this. Problem is, we don't want to go up there and show this presentation yet until we can. And we're almost done with that. We've also been working with the Casa Force and Archery Club. We've been able to field test and look at all these different angles and test everything through them. So it's been great to have that support. And our team, our collaborators, also has an extensive amount of patent experience when it comes to buying some of these patents. We do have some support for that. Feasibility, when we developed this sexy prototype, I like to say, it was from off-the-shelf equipment, just to prove our point, just to prove our testing methods, and this does work. So we're able to create some of these items from off-the-shelf items. Now the numbers we're asking for as well, when we look at the critical issues, we need some help as a consultant to go out there and formalize our business plan so we can go and present some of these things. We're also looking for some expertise in some of these financial areas and some money to go and travel. So when it comes to some of the additional support that we're asking, it's going to be about $16,000. It's pretty cheap right now. We're looking to go out and we're looking to go out and start making this money right away. Because we're not going to be taking a while to start out. We're not doing that. We're looking to collect this as soon as possible. So we want to thank you very much for giving us the opportunity to be here. We're also looking to, if we're profitable, to donate a certain share to Cal State Fullerton. So we can create a scholarship. So we can look back and give back to our university that's given so much to us. I want to thank you very much for giving us the opportunity to be here. We truly believe in our product. We believe that this can revolutionize archery, not only in the United States, but in the world as well. Thank you.
That was Eagle Eye Engineering. Panel, do we have questions?
How precise does this device need to be in setting it up and adjusting it? I mean, does every range need to have an engineer on staff to change it for the distances, or can I put one in my backyard and just pull it up and down wherever I need to be?
So the production design that we have, which we showed earlier, it has a number where you can type in your go speed, you can type in your distance, push go, it'll go up to that distance. So we have tested this, it's pretty accurate. Our Castle Force archery team has been prepared for a competition after the competition, and we're using this prototype. And it helped, it's pretty easy to use.
Okay, we just said pretty accurate. How accurate is pretty accurate?
It's accurate to the point where when they go out and practice outdoors, it's about the same target, the same distance to run calculations.
Can you talk to me a little bit? I think I'm confused about who your actual customer is. Who do you imagine is going to actually be buying these?
Right, so we're looking to talk to some of the large companies such as Morale and Whitetail. Looking to go up there and ask them for this.
Sorry, I don't mean who is the potential licensee or whatever. If your products exist, who's going to be buying them and why and how? Tell me a little bit about that.
Perfect, great question. So it goes back to some of these. When you look at Castle Fortune, they have an archery ranges all across the world, all across the nation. Be purchasing these so they can emulate that outdoor distance indoors. They don't need a range to be able to practice outdoors. There's archery ranges, universities, Olympics, and all that.
That's what I thought. So it's the archery range that's your customer. So can you tell me how many archery ranges there are, say in the U.S. and North America, someplace?
There's thousands right now with research. There's a lot of them. In Orange County, there's 4 outdoor ranges. So we looked at kind of based on Orange counties. But indoor ranges, it goes up to over 50 indoor ranges. Outdoor ranges in Orange County is about 4. But over the nation, it's one of the fastest growing sports. It's really picking up fast. But when it goes to outdoor ranges, they try to practice outdoor, but there's lack of space in some areas. So there's a lot of them.
If I may, you guys are all engineers, right? Smart engineers, right? Are you the only engineers in America? No, right? So my question goes to why you believe the barrier to entry is as high as you set it in your projections. How can this not be duplicated or some other system be implemented by a competitor?
We've looked to cover this, but the mathematics is pretty simple. So therefore we'll cover our methodology in the patent. It'd be really hard to break the patent. And we're going to have a low licensing fee. So a big company trying to go around our patent, I don't think it would be hard.
But what is your patent for, right?
It's for the algorithm, where the speed, related to speed to the height and angle of the target.
Right, and that's what I'm saying, that you need one change and you've got a different algorithm, right? So, unless this is the only way in the natural known world to do this, then you're open for competition, right?
Definitely, there's also going to be a general competition, of course, in the business and concept. We're looking to cover up all our algorithms. When we're going to file a patent, that's going to have to be smart, that's going to have to file it and make sure that the different angles can go around it or not. So we're looking into that as well when we're going to submit.
Yeah, it's just, especially in the software side, we find these things, you can get a patent, but they're really unprotectable because of the nature of the algorithms or the software itself. So is there anything else that you have that is IP equity?
Definitely, it's that as well as the target faces. These faces are especially created for that. The way it's going with the special tilting, features, that's all going through that big package.
Okay, thanks.
In doing this, you put the target up there, and the person that's using it is actually aiming at a target. When they're outdoors, they're just, correct me if I'm wrong, they're just kind of pointing in the air and hoping they hit the target out there. They don't see the target right in front of their arrow, so doesn't that make a big difference?
They're actually aiming at the target. This is the scope right here. They look at the target and then they use the scope, they'll look at downrange, football field, whatever length it is, and they'll see the part of the target. That's what the emulated base, what they would see at 18 meters compared to the longer distances.
So if they're actually shooting outdoors, I'm assuming the scope is at a different angle than you're actually pointing the bow. So that's like,
Exactly. So typically when they go and try to shoot outdoors, they've already had their sights and everything measured for that distance. So they already know that they need to get this sighting to be able to shoot at that distance. So when they look at this and they adjust it to the same settings, it will look exactly the same.
got it, okay.
That's the methodology.
right, guys, you're the rocket scientists, I'm the stupid banker, but I got the money. From the physics standpoint, you've got a portion of this physics standpoint, the angles and decreasing of the size of the target. You have to put into play the size of the arrow at all. Does that not come into a factor? Again, stupid banker. Does that come into play?
Good question. The only factor that really comes into play is the velocity of the arrow. So we calculated that the various velocities that bows generally are from, they have different heights compared.
Okay. Second question, because you have a smaller target and you're still using the same normal sized arrow that's normally shooting against that large target, you're ripping up targets in a big hurry, aren't you? Have you got more cost there to the client, to the archery range? Are they having to go out there and constantly change these things down, bringing them down, pushing them back up, and all that?
So typically in archery, that is an issue with any stand that they have. When they're practicing archery, you're going through these things really fast to start with, because you're punching holes and all that. So this is the target face that they can easily replace. And the targets, we've also made these targets compatible with some of these large manufacturers, some of these large industries where they provide their own, they can fit their own in here as well. But you can replace the target faces, and the target face is relatively cheap. And we've also added 4 in here. Typically when you have an archery stand and an archery butt, you'll only be shooting at 1. We've added 4 just in case that can, 4 times the amount of arrows that you put in there. So.
On this particular one, it not only goes up and down, but you're saying the face rotates. Okay, and that's done automatically. There's some kind of processor, right?
Correct. So this one right now is going to be manual. We have to put screws in here and knob in there and charge into that stuff. The end is being raised up by an automatic winch as well. All you need is a drill. We developed this head, you just put in the drill and it goes up and down, so it's really easy.
So you would have 2 motors, one on an X and one on a Y axis, is that?
Right, but then the production type, there's different. That's going to be automatic. It can go to different places.
So you mentioned that 33% of archery ranges were in the Midwest and another 33% were in small towns. And then you also have the indoor ranges. So it's kind of a combination question. How does this fit inside of an indoor range? I mean, does it fit? And then the second question is, in the small towns where there are, or in the Midwest, where it seems like there wouldn't be space issues, but you said there were weather issues. Now, are there indoor ranges in those towns and in those areas that this would apply when there is a weather condition?
Yes, the first question was, how are we going to fit this thing into some of these archery ranges? Well, the production prototype that we have built, it's going to be collapsible. And the image is going to be transportable, collapsible, with the wheels on there. So they'll be able to bring it down up to 5 feet, and they'll be able to move it around wherever they want, push the button, pops back up again. So it is transportable, it's collapsible, to be able to maneuver in different areas. This, of course, is a prototype. Even this is collapsible if you can take off a few screws, or you can put it in. In some of these Midwest and these ranges as well, they do still have those problems. They do have the indoor ranges, and many of these, it's mostly popular in that Midwest area, so they do have a lot of ranges.
What kind of a ceiling height do they need to do this indoors?
It's about approximately 13 feet.
And most ranges have that kind of.
Yeah, Jim.
So I'm really curious. Where's Morel? Is that the name of the company, Morel?
Yes.
Where are they based?
Morel is based in, I believe, Arkansas.
Okay, so let's suppose you get them on the phone and they say, sure, come in and show us. How are you going to do this thing?
Right.
What are you going to do?
We're looking into showing these pictures of prototyping and all that data. We're hoping that the first time we interact with them, we talk to them about the business plan. Of course, once it's packed into